చెప్తున్నా అంటే అనుకోవడం అని కాదు కానీ ఇవేం ఫీల్ అవుతుందో అని చెప్పి ఆమ్లెట్ అని అంటే వేసుకోండి అంటే ప్రాబ్లం లేదా అని అన్నా.
All right, guys. Welcome back to ITS 520 Machine Learning. All right, so we're going to continue now our discussion of TensorFlow 2 and some of its new modules. Okay, so I think everyone is coming back at this time into the course. All right, so you know, hopefully at this time everyone is seeing my screen share of Scholar. All right, so I'm going to go back to the code. I'm going to go back to the code here. All right. All right. So we've completed our examples of just tensor operations in general, and also of the discussion of the TensorFlow 2 datasets module. Right? So we've covered that already, so hopefully that gives you, we'll obviously practice it a little bit more because we were going to integrate this with, when we started building models in Keras, you know, both of these things can be used together. But now we're going to move on, we're going to stay within the topic of data, and now we're going to move on to the next section here, which as you can see is loading image data. So far in the semester, we have covered quite a bit of text processing, where we looked at how to, you know, read data from Twitter and so on. And then, you know, we looked at the bag of words approach, count vectorizer, and so on to represent tweets or text as feature vectors, right? So we take text, tweets, or sentences, and we converted them to feature vectors, and, you know, with labels and features. Remember, all of that has to be numeric data, and then that, you know, we use to train and test in a supervised learning approach with our supervised learning algorithms. So now we're going to repeat the same process, but this time, as you can see, we're going to be loading images. So now that is the goal. The goal is to load images here. So you can see I'm going to start here in this section. You know, I'm just going to call it now loading images. All right, so I'm loading images. So these images are, you know, they're, as you know, in the GitHub. So now I'm going to go in our GitHub. If you look, I have images. I have an images folder here, right? And we can actually visit that in the File Explorer. So if I go to the File Explorer, go up a level, so in TF2 Basics that I created, that I downloaded from the GitHub repository, I have my folder zip, which I unzipped, and I created this little folder called images, which has something called fruit in it. And then I have, as you can see, I have 5 examples of apples, 5 examples of banana. Notice that these are color images. And if you right click on them and go, oops, I did not want to do that. I did not want to do that at all. I did not want to set this to an apple. How do you revert back to the Purdue? Anyway, I'll have to figure that out. Anyways, all right. Where was I? Yeah, in the File Explorer, right? So if you right-click on this, and you go to properties, right? Then you go to image, and you will see that this is 100 by 100. Okay, so this is 100 by 100. And so what that means is, just like with MNIST, that it's one thing that we've looked at before. We know that whenever we have a two-dimensional matrix of 100 by 100, what we've done is we've stretched it, right? So with MNIST, which was 28 by 28, we stretched it into a vector of 784. So here, you might imagine that we could do the same, 100 by 100, that would, multiply them, and then we would get the size of the vector, which is quite large. So those kinds of operations that I just discussed are the kinds of things that now we need to think about, okay, when we're dealing with images. We need to deal with those dimensions. So that means we're going to be doing a lot of reshaping of these things. Also remember, because these are color, in fact, these are not grids or two-dimensional arrays, but three-dimensional, right? They're going to be, in this case, this one is 100 by 100 by 3. Because remember that color images have 3 grids of 100 by 100, one for red, one for blue, one for green, which those combinations allow you to determine the final color of an image. All right, so I'm going to go back to the terminal then. And just remember, the key thing that we need to figure out is we're going to need the path, right? The full path of this. So I'm going to go into images, LS, and then I'm going to go into fruit. I'm going to do LS. The images are there. So then PWD, that gives me, for my case, because I don't want to move the images really, although I could, that's probably the best approach. Actually, I could plug in the path, or really, I can just go into, so I'm in here, right? And I can just copy these images, control copy, move them into basics, paste it in there, and then that way I can just use the current working directory and not have to specify the full path. All right, so now that I move the images, I can go back to my code. I'm going to need to navigate out of this. Do that again. And now I'm going to go back into basics. All right, and there we are. So the code should be TF2 examples. So I'm going to click on nano, TF2 examples. And now I can scroll all the way down to the section that we were working on, which is the images. So one thing that we're going to be doing here also a lot more of is plotting. All right, so this code is actually 2 things. One is, load images, right? That's one main one. It's actually 3 things. The other one is, so the pipeline is basically you load the images. Then you do things to the images like reshape and convert in some type the images to something that looks a little bit more like vectors, right? So we need to reshape and convert to vectors. So this is similar in the pipeline to cleaning, right? So when you did a lot of the examples with text, you had a lot of cleaning to do, and then you convert it to a vector. Here we sort of do the same, but the operations, there's not really noise anymore. The image, you can basically include every pixel, right? You can use every pixel, or you can downsample, because an image that's 300 by 300 RGB is actually quite large. And so you can always downsample, but the pipeline would be in general loading images, reshaping them, converting it in some way to vectors, and you'll see examples of that in my discussion today. And then finally, a lot of it sometimes is just visualization. And what that means, that visualization part is not really part of the machine learning pipeline. We don't need to do it, but sometimes this is good just so that you know what things look like. So it's really more for you than for anything else. And usually I'm just always going to refer to that as visualization. So it's a part of, not necessary to the pipeline to get to the results, but useful for you. And just remember, whenever we do this, you're most likely going to be using Matplotlib. So the Matplotlib library, all right? So just be aware of that. However, I'm not going to be covering Matplotlib in this class, okay? I want you to know that. So we're really just going to use the code as is, because Matplot would take too much time. It's its own thing. It's an extremely powerful thing. So I'm gonna leave this basically, anything that has to do with visualization and Matplotlib, I'm going to leave it for you to figure out. But I've already given you the code, okay? And usually you just have to use it as is. So certainly study this on your own. Again, that's why we created, 265. 265 will cover Matplotlib as a topic itself, whereas here, it's not really something I'm covering per se. But I leave it to you, and I will be using it here just to illustrate how things look. All right, so now that I have my code here, you can see this one's a little bit more extensive. But it's basically because it includes those three different things. Okay, it includes those three different things. So let's go through it sequentially. Right, since the first thing we need to do, given that the files, given that all the images are now files, right? So it's no longer like you go to Twitter and you download some text, some tweets into a text file and then you read them. So that's no longer the case. Now the case is that you have, as you're very familiar with, a folder. And in the folder you have files. And notice the files that are apple start with the word apple. The files that are bananas start with the word banana. And these are JPEGs that are 100 by 100 by 3, as we described before. So now then, we're going to need to import pathlib, which will allow us to basically read the contents of a folder. All right, this will allow us. So usually the standard practice is you have a list of the names of the files. Okay, you have a list of the name of the file. You iterate through that list, and then once you've iterated through that list, you can read in each one of those files into your data set somehow. So the first example will be just about that, reading the data and viewing it, the visualization part. So you can see here, I'm going to use pathlib.path, and I'm going to specify images and fruits. That's exactly where my images are located because I moved them into the current working directory. And then I created an image directory path. And now I'm going to use a list comprehension. You can see that here for path in image directory path, which is that, right? And then I'm going to call for that object the function glob, right? And that just specifies a wildcard that says asterisk.jpg. So every file with an extension JPG will be loaded into this list. And by the way, through the list comprehension, for path, every single time I load one, I'll convert it into a string. So they're going to be stored in this list, and you can see the square brackets there. So the list comprehension saves everything to a list, and then that list is going to be passed to the function sorting. And this function, as the name implies, is just going to sort things. And then now you have your little file list, and we're going to go ahead and print it. So that's the first thing I'm going to do. So let me add the comment here. I believe I have, yeah, so let me get rid of this one. All right, so this should give us the list of files. This is something that you know, when you took 372, these are the kinds of things that we did a lot in that class. So this should be familiar to you. I'm going to go ahead and now I'm going to run it. Probably need to type it. All right, so you should be seeing my terminal, and I'm about to run the code. All right, great. And Matplotlib, thanks to Mitch. You know, Mitch, you know, I can't stress, Mitch helped us out a lot by creating those Anaconda environments, because as you can see, all the libraries that we need are there. And so really appreciate that. All right, so now you can see here in this list, I have all the file names, right? So I have images, fruit, apple 0, apple 1, apple 2, apple 3. I sound like I'm talking about Macintosh. All right, and then banana, you know, R241, R242, and so on, right? So I have all the names in there of my list. So as you might imagine, now it's just a matter of iterating through this list. So let's go ahead and do that. I'm going to clear and go back to my editor of choice, whichever one you want to use. Scroll down, and then we can see here. Here. Now, I'm not really going to convert the data, the feature vectors in this code. So we're really just going to focus actually on the load images part, which they're going to be loaded in a second, and the visualization. And so now I'm going to remove these comments out. Notice that the first thing I do is I import Matplotlib, okay, which is, as you might imagine, that the visualization library that I talked about before. And then whenever it's something with visualization, guys, as I said, I'm just going to use the code as is, okay? So here, I'm gonna leave this to you guys, but basically, usually the standard approach is you create a figure, specify a specific size for it. And then after that, notice here, we're gonna enumerate through the file list so that we can iterate through all the files. So we're gonna grab the index and the file name. And then notice the critical thing here. We use Tensorflow has a built-in module for loading image data. How convenient is that? So that's really one of the great things about TensorFlow 2, okay? That now it's got all these functionalities. And so in this case, we are going to go ahead and we're going to go ahead and use TensorFlow dot input output, right? TensorFlow's dot input output module, and then we're going to read a file called file because it's the one we just iterated through, and then we call it image raw just to indicate that it hasn't been processed. Then after that, we have tons of functions. You know, one of them, for instance, is tf image dot decode image raw, and that's just going to, you know, usually these JPEG files sometimes have all these layers, and we just want to end up with a few layers, right? So, but the key question is, what is the current shape of my image? Okay, what is the current shape of my image? You know, so it should be 100 by 100 by 3, right? But you always want to double check by doing image shape.img.shape, for instance, right? So that intuitively you should know that that will print out. So we're going to be looking out for that. And then everything else, whenever you see this AX, that's the convention for something related to a figure. And you can see we're going to add subplots. As I said, you know, I'm just quickly going to go through this, but this grid will allow us to plot the images, right? So our goal is to create a plot, and then you can see we're going to do an IM show of all the images and show them in a plot. You can give it a title. So in this case, it's going to be probably the file name, all right? And then once you've set the figure, you always do plot show, and that should show us our figure. Okay, so we're gonna go ahead and undo that. All right, so now I'm ready to run the code, and we should see our fruit. Okay, so I'm gonna go ahead on that. Uh-oh. Matplotlib is not there.
You just gotta install it using pip.
Pip. Pippin. So guys, follow along here.
I think it's pip3 install.
Pip3 install. Can I do this with conda? Can I just say conda install matplotlib?
That's a good question.
Yeah, you should be able to do that.
Yeah. I just don't like, you know, like when you do pip, it might add a little bit of an inconsistency. Let's try it. So conda install matplotlib, right? So it should install it on this module. Let's see what happens. I hope I don't break it. Okay. All right, so now hopefully Matplotlib is there. Let's try it. Ah, there we go. All right, so great. So it printed out, as you guys can see. So we got two things going on here that are very important. First, we want to double check. Remember, it's called TensorFlow for a reason, right? We always need to know the size of our tensors. Right now, we loaded 10 images. Here they are. Right, here are the 10 images. And they are size 100 by 100 by 3, which makes sense. The 3 is for the RGB, and then the 100 and 100 is for the grids. So that's good. All right, so let's run it again. Sure. Out of memory. Okay. That's strange that this would be out of memory with such little. Well, let me just start it again. I'm gonna do bash. And then I'm gonna do desktop, and then I'm going to do ITS 520, and then I'm gonna do LS, and I'm gonna do TF2 basics. Oops. So then I'm gonna do basics, LS. All right, so it should be TF2 example. I also need to then go to conda activate TF GPU. And then now I'm going to do TF2. So let's just run. This should work, hopefully. Nope. Okay, what is here? All right, there's some, I must have something in my, because it says TF variable initial value 1, 2, 3 var X. I mean, I closed the terminal, so it's giving me an error somewhere around here, which we know that all of this was working before. It's this TF variable. So there's obviously something going on. Closing the terminal should have taken care of that, actually. So, I don't know. I can't shut down. I don't think I can. I'm going to, no, that, all right, I logged out anyway. Give me a sec, guys. So you should be seeing the this again. So okay. Let me try this again. Okay, so I'm going to go into basics again. I'm gonna have to run bash again. Conda activate TF GPU. Okay. Try to run this yet again. Okay, all right. So this happens sometimes. I don't know. Something got locked in the. It wasn't an error in the code. Obviously, it was an error in some memory issue. Something got stuck in there. Usually, I would have just restarted my computer, but given that I don't think we can restart these Scholar ones, I don't know, I was able to, maybe it cleared on its own. So anyway, hopefully that error will go away. But you can see here, all I did is I'm viewing my images 100 by 100 by 3, and then I also printed them out with Matplotlib for visualization purposes on here, right? So this, it's good. Although you already knew what they looked like, this is useful in particular. Let's say that we were downsizing the images from 100 by 100 to, let's say, 20 by 20 or 30 by 30, then you would want to see them again to kind of see how blurry they looked, right? To see if they were still good in their quality, I guess. All right, so now we visualized them. So let's close this. The code finished executing. I think maybe before I didn't finish. I hope that was the problem. So now I'm going to go back into the code. So you guys should be seeing right now the code. Or rather, I'm going to the code right now. So I'm opening Nano. And I'm going to scroll down. So you should be seeing me scroll down in the script itself to that section where we read the images. And we're just going to keep looking at what else we can do. So at this point, we're here. So I use the module to read the images. Then I call Matplotlib. Then I read every single image, decode it, and basically looked at the dimensions and plotted the image. The next step is now I'm going to move these comments out of the way, right? And I'm going to scroll down here. And now I'm going to, as you might imagine, I have the images. Now I need to have labels. So again, once again, I'm going to create a list comprehension, right? You can see that here. So I'm going to say for loop here, for file in file list, so I can iterate through all the files. That means I'm going to have the file names, right? So then I'm going to say, in front of the for loop, I'm going to say 1, this is a 1, so that means assign a 1 if the word apple is in os.path base name file. So if the name is in that file, apple, you assign it a 1, else assign it a 0. You see that there? And this is, once again, because it's a list comprehension, it's going to result in a list of 1s and 0s depending on whether or not the word apple appears in the name of the file. Right? And then once we've done that, we can print the labels, right? And you're going to have this, 10 labels for 10 images. And then after that, look at what we're doing here. tf.data.dataset from tensor slices. So we're basically going to do the same thing we did before with the dataset module, right? And now we're going to use a tuple of file list to labels. So notice the data is still not there. We just have the names of the files and the corresponding labels. And that's going to be used to create the object ds file or ds underscore files underscore labels. And then once I have that, I'm just going to print, I'm just going to iterate through it as we did in the previous examples. So in the dataset module examples of TensorFlow 2, I'm going to say for item in ds files labels, and I'm just going to print out item 0 of the tuple, and then item 1 of the tuple. Okay, and so that will be my approach. Now, if we look at file list, the last time we used file list was up here. Okay, so this is the last time that we used it. All right, so now let's take a look at it. So we're going to run this code again, or now we're going to run this code so that we can see our images data is now represented a little bit more as a data set. So here, when this gets annoying that you don't want to see the plot anymore, you can always just comment out that line. We're going to do that in a second. But basically, here is our data, right? So first of all, here we converted the apples to ones and the bananas to zeros. And then here we have the data set currently, labels, and the data set name. So we still need to read the data. We can't do anything with just the names. That's like having the labels there. We actually need to convert those images that are 100 by 100 by 3 into feature vectors. Okay, so I'm going to go ahead and get back into the code. Are there any questions so far? Any questions? All right, so let's continue then with the next part. We're doing well on time, so let's see. So we got as far as this. I'm going to comment this part out, the plt.show, all right? Because since this is just visualization, you don't actually need it for the machine learning part. So we did this, right? So now we can move on to the next section. And I'm going to remove that comment. Notice here that I'm going to have two things. I'm going to have a function, right? We're going to define a function here called load and preprocess, which will take the path and the label, okay? So this will allow us to resize the images, remember, and transform them using the .map function, right? So for instance here, this will take the list of paths and the list of labels, right? And then we'll be able to process them. So notice here, we're just going to use the built-in TensorFlow input-output read file with given the path, load it as a tensor and create the image tensor. And then now we can do tf.image.decode JPEG, okay, with image, and we're going to tell it that we want the 3 channels. So remember, that's the channels for RGB. The function just allows us to do that, to specify the channels we want. And then after that, I'm going to resize the image. So I'm going to do take the original image, and I'm going to do tf.image.resize, and I'm going to take image, and you can specify the new image height and the new image weight, whatever you want. You can hard code it here or pass it as a parameter. And then notice over here, then once I do that, I can also do image divided by 255, okay? So if I take 0 divided by 255, it's 0. If I take 255 divided by 255, it's going to be a 1. If I take 127 or so, it's going to be about 0.5. So basically what I'm doing is what? I'm normalizing the data. Notice, in this simple little approach, I normalize the data. Remember that these values go from 0 to 255 in each of the R, G, and B grids. And so what we want to do is we want to normalize. That is always a standard approach. And then finally, the function will just return the images after they have been read, processed, resized, normalized, etc. All right, that's the function. Any questions on that function? No questions? All right, so now then, I'm going to specify that I no longer want the images to be 100 by 100. You know, I can just specify them to be image width 120 by 80. So play around. I strongly recommend that you play around with these values, okay? Play around with these values so you get a little bit of intuition. And then those are the same names over here, image height and image weight. You could always pass them as parameters or arguments in the function as well, if you'd like. But basically here then, we're just gonna do, you know, data set images labels, right? And we called data set files labels, which is the one we have above. So we created DS files labels here. All right, so now we're going to use whatever's in there. But once again, we use the map function. And what the map function does is it allows us to then say, yeah, take all that data and modify it through a function. In this case, it maps to the previous function, load and preprocess, which is this one. And given that our data is a tuple of path and label, so DS files labels is a tuple of path and label, right, of two things. And so the dimensions are going to match there. Right, and once we do that, then we're going to have DS image labels, and guess what? They're ready. They have been processed for us, okay? And so now we can go ahead. So if you can go ahead and play with this, you know, change that to 80, for instance. You can make it 50. So I'm going to make it 50. Actually, 120, right? So what I'm going to do is I'm going to say 50, comma 50, and pound sign. All right, so coming out these two, all right, and now do the mapping. Notice it just takes one line, and then after that, I can go ahead and once again plot everything. So I'm going to, you know, and again, play with these values. You know, I always recommend the best way to learn is just to practice these things. So create a figure. Then I'm going to enumerate through DS images labels, which is the result after the mapping. And I'm going to print out, you know, the index and the example, create some subplots, and then image show. And I'm going to show the images. I'm going to provide a title here, and then plot show. So I'm just going to move the comment down here. And then this way I can run the function. Yeah, so that should be, I commented out this plot so it doesn't print out anymore. And now we should just see the plot after running through the function and resizing the images. So I'm going to go ahead and run that. Hopefully it'll work. Ah, there we go. So as you can see, we have the new image. Notice that in the old image, we had the old name, right? The old name. Here in the new image, it's not the name anymore, but instead it is the class, the label. Okay. Questions? Questions, guys? Everything clear so far? All right, so it seems like everything is clear. So all right, so let's try 10 here. There. So do you guys see the difference this time or no? What's the difference? Who can tell me? What's the difference now between what I showed you before and what I showed you now, what I'm showing now? What's the difference?
The images are a lot more pixelated.
More pixelated, right? Which means what? That they're more pixelated.
More data is missing from them.
More data is missing, exactly. That's the perfect answer. So in terms of machine learning, you've lost information. So why do you do this? Because you do this to make it more what do you call it? More, you know, less resource intensive for your computer. So this is something you guys would have to do, right? If your computer can't handle the RAM, the memory issues, you'd have to downsample it. But there's basically a curve. It's like a balance. You know, remember, every time you downsample this, you are losing data. And the more data you lose, the less likely machine learning might be. It might be for machine learning to figure out the pattern. Okay, so you just have to be aware of that. You have to strike kind of a nice balance. Okay. All right. So hopefully that made sense. So let's keep going. So we're making really good time. And that, you know, that kind of completes the exercise for loading the images. So now almost you know how to load the images here. So let's go ahead and I'm going to make these, you know, just change these back to the original number. All right, so that's done. And we've covered this. So I'm going to remove this comment now. All right, so that kind of for now, that's that illustrates what we want to do, because, you know, the function set, oops, now the data set, you know, read the image, decoded the image, resized the image, and now it returns image labels. So what could make sense to do now is to once again do this, right? So once again, we're going to print out this one. So I'm just going to copy this. The last thing, we want to look at the data. And so it's called, so it is now called DS images labels, right? So after the plot, the last thing I want to do is I'm going to print out the contents themselves of the data. So I'm still going to leave the comment in there. And I'm going to do for item in DS. It's no longer DS files labels, right? Because now it's DS images labels. Yeah. So then I'm going to iterate through that, and I'm going to print item 0 of the tuple as a numpy, which is the data, and item 1 as the data. Another thing we could probably do is print shape. So let's see. So these are the kinds of things you would always have to figure out, right? So image.shape, for instance. You want to take a look at the shape and so on. So let's go ahead and do that. Run it. All right. We probably want to comment out those two graphs since we don't need them anymore. Ooh, didn't like it. Object has no attribute shape. All right, it's a tuple. Okay. So then what I need to do is I need to go over here, and instead I'm just going to say item 0. That should have, because that's a tensor, and then I'm also going to say, actually I can, let's just do shape. Yeah. And print item 1 dot shape as well. All right, so I'm going to do that one. All right, try it again. And there we go. So you can see here, now the data is in there, 80 by 120 by 30. You can see the information there, right? And it's just printing out the information. See? So there's the data. So this is handy if you want to explore your data and so on. get a feel for what's in there. All right, your 10 images are there. All right. Any questions so far? So it's, remember, you can always follow along with this, just reading the book in the course, the Python machine learning, right? So you can read a little bit more about this on the book. All right, so the next thing is, so now we are done really, that's it, right? So that's as far as, so hopefully if this was clear, so I hope in conclusion I should say, now you have a way of taking any set of images, any JPEG images at least, and creating the data set. So basically what I left there for you, after doing this, now you might need to do a little bit more reshaping here and there, depending on your problem, but you would be ready. Your data set would be ready to use it in Keras. Okay, that's the trick. So your data set would now be ready to be used in the Keras, module. All right. So now that we're done with that, let's move on to the next section, which will be to use the built-in data sets in TensorFlow. So as you can see here, we're going to have to run this command. We're going to run pip install TensorFlow -datasets. And that will allow us now to bring in the data sets into our environment, into our Anaconda environment, so that we can then have access to Iris and MNIST. So the next set of examples, I've shown you how to load your own data. Now I'm going to show you how to just do a little bit of machine learning with the built-in data set. So first we're going to install TensorFlow datasets. So I'm going to do pip install TensorFlow datasets. All right, so that should be installed now. Okay, we can go back to the code then. Scroll all the way down. All right, and now we have over here, if we scroll down, keep further down here, we're gonna do, all right, so we are in images. All right, so we should be here. All right, so we're here. And now the next thing we're going to try to do is we're going to try to use this TensorFlow datasets module, okay? So now this is a new thing. We're starting a new section here. So I'm going to add three lines. Okay, so let me add this one as well. Oops. And we've run the command. So now we can just go ahead and import from TensorFlow dataset, or import TensorFlow datasets as tfds, right? So we're going to do that, and then we're going to check that it works by, first of all, we're going to look at the list of the builders in this dataset, right? The list of the datasets themselves, so how many we have, and then we're also going to print out the list of the top, let's say, instead of the top 5, let's try the top 10. I think there's at least 40 or 50 data sets on here. And they're all, and keep in mind, they're always changing things. So they're, this is always changing. So let's go ahead and run this code. Should be pretty easy and straightforward. All right, so I'm gonna hit Python here. And then now, so I'm going to do that. All right, there they are. So there's actually two currently, as of today, because I just installed it, there are 231 data sets in there. All right, so then, you know, I can probably then list more than, you know, let's say, let's just list the top 50. So it's still readable somehow. So I'm going to do here, you know, the top 50 data sets. All right. We do Control X, Y. All right, now I'm going to run it. All right, so I did this. Okay, and now we can see, here they are. So some of the important data sets, if you guys can hear me, you can see yourself. There's accent database, Amazon reviews. That's an interesting one. So if you guys like to play with, you know, things, that might be an interesting one. It's probably like comments that you find in Amazon. What else? Caltech 101, that seems interesting. Birds, something about birds, cars, cats versus dogs. So that's probably images about cats and dogs. Celeb, this is always a fun one that people like. It's pictures of celebrities. You can play around with that one. CFAR 110, these are important ones for challenges. Citrus leaves, so, you know, leaves and fruit. Cityscapes. More comments. CNN Daily Mail, I assume that's news articles. And so on, right? So there's 231. You have a wealth of data sets that, you know, if you're bored, you know, play with it. You know, apply machine learning to all of these, right? They're going to be labeled. So for supervised learning, they're going to have labels. There'll be images. There'll be text. You know, play with it. So at some point, I might give you a homework assignment about this. But just be, and MNIST and IRIS will be here as well somewhere. That you can see they're in alphabetical order, so, but they're there. All right, so now let's go back to the code. Can you guys hear me? Are there any questions? You've been very quiet. You guys still there? All right. So now, let's see. We are, all right, so we are here, right? So we are here. We've completed this part, so you've seen the data sets built into TensorFlow 2, which is very valuable. And now let's just view some properties of one of these data sets. So let's pick the celeb A, which is the celebrity one. So just to see kind of the pipeline. So the way it works is you invoke basically tfds dot builder, and then you tell it that you want celeb A. You tell it the name. You can view it in the list, and then you just create your object. Now you can print out information about it. So you can do by using the .info module there. So you can say info features, and then I want info features image, and then I also want to print out some attributes and keys, maybe the citation and so on, right? So there's a lot of wealth. I leave that to you guys to explore, but there's a wealth of information there for you to use. All right, so we can go ahead and run that one. And there you go. So information about the images. Let's see, you've got this is just a warning, I think. So it shouldn't be an issue. Here it provides the features, you know, some attributes associated with this. The information about the images, you can see that they're 218 by 178 by 3, so they're color images. You can see things are annotated, left eye, nose, right mouth, and so on. Remember, these are celebrities. You know, there's features like does it have an earring, things like that. And then there's the citation of the people that wrote an article about this data set. You can see that there where it's so you can look for it, right? It's an IEEE paper, it seems. And here's the title. It's called Deep Learning Face Attributes in the Wild. So, and actually the URL is right there. You can probably download it from there and have fun reading the article. All right, so just, you know, that one just gives us a little bit of information about the data sets themselves. All right, so now we are ready to continue. So we've done that. So celebrity, somewhere in here. All right, so we're done with that. So now, we can, yeah, so we can skip this. And then let's actually now, I believe, I'm just going to remove this. Okay, I think, let me just check that it won't error out. So this should work. These are just comments. I think I'll just get rid of that. All of this will run. These are comments. This is a comment. All right, so I think here, right? So this is where we want to be. So now that you've seen how to do that with tfds, we get back. So now we, you know, we kind of play it with that a little bit, and now we are ready to get back to machine learning. So that means we need an actual data set, and we're going to continue what we've been doing, which, you know, when we started the semester, we started with Iris and MNIST. You should be familiar with those two data sets. So now we're going to use tfds to load MNIST. However, you already know how to load MNIST with sklearn, I believe, and so you can also try doing it that way. But here, I'm going to take tfds.load, and I'm going to tell it, you know what, I want the MNIST data set, you know, the handwritten digits. It should include the information, so that's, I'm going to say that true. And should I shuffle the files? No, don't shuffle the files. I don't need that. And so then I can just store, the actual data set is going to be an MNIST, and then also I'm going to have MNIST info, which allows me to print out some data about MNIST. Then after that, I'm going to print out MNIST.keys. That'll give me a little bit of information about it. And then you can see here, I can actually, from MNIST, I can call, I think MNIST has train, test, and validation. So here I'm just going to call the MNIST train, which if I remember correctly, it's either 60,000 or 70,000 samples. All right, so I'm going to take that entire data set, and I'm going to create my object handler ds train. Right, so I'm going to create my object handler ds train. Then I'm going to do ds train dot map, just like we did before, exactly like we did before, right? Exactly. What do? I'm going to apply a lambda to the item, right? And all I want is I'm going to take that object, that is the item, and I'm going to make it into a tuple, right? You can see that I'm creating the tuple here, you know, in here. So the tuple now has these two items, which are item image and item label. All right, so it's like really like I'm going to create two tensors, one tensor of images and one tensor of labels. How many classes do we have in MNIST? You guys should know this by now. How many classes or labels?
10.
10. How many features?
784.
784, right? Because it's 28 by 28. Remember that MNIST is black and white. So really, if you look at the tensor, it's 28 by 28 by 1, right? So these are things I want you guys to memorize, if you will, because they help you a lot when you're using other data sets to be able to kind of compare them to the ones that you know. All right, so then we are going to take our train set, ds train. We're going to do this mapping with a lambda option, create the tuple of images and labels, and then now that's the new ds train. And then we're going to do here, let's just say I'm going to take the first 10, or I'm going to define ds train, which has 70,000 samples, right? 70,000 samples. And I can look at the batch. I'm going to set the batch to be of size 10. So I want batches of 10 whenever I read my data. And then after that, I can use the iterator, right? To kind of take the whole ds train and create like a list of it that I can iterate through it. And then I'm going to grab next. That allows me to grab the first batch. You would do this usually in a for loop, remember. And then now I'm going to do batch 0, the first one, right? Or in the first batch, I'm going to take, in the first batch, I'm going to now have, because I did the mapping function over here and created the tuple. So this is 0, this is 1, which basically means that over here, I can now grab batch 0 and batch 1 and print it out. Because this is going to have so much data, I'm just going to print out actually the shape. Usually when you start to when you have 28 by 28 by 1, and then you have, 10 of these in a batch, that's too much data to print out. It's not so meaningful as much as looking at the shape is. So really looking at the shape is all that I want. Okay? So here I'm going to print the label and also the shape of the images. So let's go ahead and do that. All right, so I'm going to do Control X, Y. Now I'm going to run it. All right, I'm going to close this one, that one. It's downloading MNIST. Notice that it's downloading it because MNIST is kind of large. If you're doing this for the first time, it'll do that. The next time around, the data will just be there, so it's not going to download again, okay? So just be aware of that. But MNIST is, and keep in mind, MNIST is still not big data. It's really a small data set, but as you can see, it took a little bit of time. So after it downloaded the data, you can see here, we're printing out, again, the info. So it's called MNIST. The description is the MNIST database of handwritten digits. The person who is, one of the fathers, I guess, of deep learning, Jean LeCun. So you can see there, Jean did a lot of work with MNIST. He worked for the post office, and they asked him to do this work, and he's one of the people that gets a lot of credit for convolutional neural networks and his work in that area. He is currently an AI scientist and the director or the president, I don't know what it's called, but the main guy of research of machine learning at Facebook. So he's over there. All right, so Jean LeCun did this work. You can see here the images are 28 by 28 by 1. You can see here it gives you a lot of very valuable information. It says the number of classes is 10, data type. Notice the number of examples, 70,000. Oh, very good. How many do we have? We have 60,000. See, there you go. We have 60,000 in the train set, 10,000 in the test set. No validation test here. I think in other places they do have that. All right, in other data sets, I guess, or modules. Supervised key, image and label, you can see that there. And then the article citation you want to cite is LeCun 2010, MNIST, and then the title is MNIST Handwritten Digit Database, and it was done by LeCun and some other people. Corina Cortez, I think that's. These are all very famous people. And then AT&T Labs, right? So, which is probably Bell Labs, the new name of Bell Labs. So Jean LeCun is there. And this is actually not that old if you think about it, 2010. You know, it's only been around for 10 years, you know, so you can see it's pioneering work, but all of this really has only been possible since 2007, so it's not really that old. All right, you can see here when we printed out the dictionary that we have basically test and train, right? So we have test and train over there. Okay, we have train and test. All right, so we have train and test there. We have also some warnings there. And then we have the dimensions. Notice here, this is the data set. Why is it 10 by 28 by 28 by 1? Why is that tensor that? It's the batch, remember? So whenever you do a batch of a data set, that's still a tensor. Before the images were 28 by 28 by 1, right? Or 28 by 28 by 3, which is a cube, you know, for the RGB. Imagine like a Rubik's cube. But now add to it an additional fourth dimension for the batches, and it, you know, we're getting into hyperspaces, right? So, you know, humans can view 1 dimension, 2 dimension, 3 dimensions. We can't see beyond that. But mathematically and programmatically, in programming, we can have multiple dimensions, which are the tensors. And this is an example of that. All right, and then that's the labels, of course. And the shape for that is 10 by 1, or 10. So everything in TensorFlow 2 has to be a tuple now when it has to do with the shapes. All right, so still have about 7 minutes, so we're doing really good time. I was hoping to finish these scripts, but I believe still have a lot to cover. I thought I was kind of finished. Let's see where we are. So MNIST, so you now have seen MNIST. We printed out basically just information about it. That's what we did over here. And then we have a plotting. Oh, yeah, I thought so. All right, so we're almost done actually. So now, as you might imagine, what's left is after we viewed MNIST, right? And you know you have MNIST here in the train set. You did your mapping function over here. We were able to print out the data. We got the batches. You could always do one last thing, which is to print the batch itself, right? So you can print the batch itself. I can do batch 0 and not print the shape, but just print the batch itself to make sure there's data in there. Okay, and so I'm going to do that again. All right, and there we go. We have and there we go. And you can see here, you know, the batch is 10 by 28 by 28 by 1, and there's your information. A lot of zeros sometimes because the background is white in handwritten digits, right? It's really just a few things that have lines in there. And notice these dot, dot, dots show you really that it's not showing everything. All right, so now the last part then for us to finish today with our code, and then I'll talk a little bit about what we're going to do next week. And I think next week we'll be able to wrap up supervised learning. So I might give you a homework assignment at that time. So now, last thing is, as you might imagine, we want to just view the data. So I'm just going to go ahead and remove this one comment there and remove this comment from there. And now all I'm going to do is I'm going to create a plot, with Matplotlib again. This is only for visualization. Notice here I'm going to take batch. Remember, batch is this one, right? That's the batch. And then I'm going to iterate through those batches, image and label, and I'm going to plot it. Okay, so you can see here I'm going to plot the images and I'm going to show them. And that's really, we're not, as I said, I'm not really going to cover how to do visualization here in this class, but just use the code as is. So now I do this. Right. And you can always comment these out in your own code. And there you go. There are your handwritten digits. As you can see, most of it is white background. You can see we have the labels ready to go. And then here are the numbers. And that's it. So at this point, we've covered a lot as far as viewing data. And a lot of concepts this in this session. All right, so let me just really quickly, in the few minutes we have left, plug, just so that we know what's left to cover. So I'm going to go to here. And you can start reading through this code, I would recommend, and read the chapters. So we are basically done with our basics, right? We are done with our basics. I still need to come back to activation functions, but we are done with that. So next week, we're going to pick up here with Keras. So the focus will be entirely on Keras. We're going to use the iris data set to build a multi-layer perceptron. You can see there MLP. And then also we're going to take another problem, which is an XOR operation. And we're going to do the same thing, classification, right, of the classic XOR problem, both of them using Keras. Then after that, I'm going to get into the activation functions. This is a very short script, so we can do that really quickly. And then finally, the more complex topic of the functional API, which is you might think of it as a more advanced version of Keras. So we're going to start with simple linear regression, which is the more intuitive, and then we're going to finish it up with the XOR operation with the functional API approach, right? So that's what's coming up. After this, you'll probably get a homework assignment on supervised learning, and then the next topic would be reinforcement learning, where we're going to look at TensorFlow 1, and in particular how the concepts of reinforcement learning and at least use a neural net, and then finally on supervised learning, and we're done for the semester. All right, so we can stop here for today, and just right on time. So let's stop here for today. I'll stay for a couple of minutes if you guys have any questions. Otherwise, make sure you finish your Twitter exam due tonight, and then I will see you guys next week. Have a good week.